what we've been doing. I know that you don't want to learn another way because some of you are just getting used to long division, and you say, I don't want to learn another way, but I understand long division. Can I just do long division on all of them? And the answer is yes, you could, but you're going to get bogged down very, very, very quickly. Because what we're doing tomorrow is we'll start testing things where we'll need to divide maybe by 4, 5, 6, 7 different things before we see if what we have works. And so if you did that many long division problems for every single problem you have, you could run out of time and you could get bogged down easily. So let me show you this. Now here's the trick with synthetic. It doesn't work all the time. It only works when you divide by x plus some number or x minus some number. No other x's, no exponents. Notice the x is just alone, just x, and then just a constant. Okay? It could be 57, yes, but this is just a constant. If there's a coefficient on x, it doesn't work. If it's 2x plus 3, it doesn't work. It's got to be x plus 3, x minus 3. Any of those work, but nothing on the x. Does that make sense? Okay. So, for example, give me one, BJ, on that paper that you have that could be done with synthetic, that one you were just looking at. Or Charlie, that one that's blank. Oh, no, that's factoring.
What if I did like so?
Or on the quiz, that's fine. Give me one on the quiz that could be done with synthetic division.
Go with 24x.
Wait, is he right, Nicolette?
No, but
We're not. That's not even a division thing.
You can't have x at the end of the problem, yo. Division problems like what we did the other day.
Give me a division problem that can
X
be done.
plus 5.
No, let's get a good. Go ahead, BJ.
Real quick.
Let him cook.
X4 plus 3x cubed minus x squared minus x plus 6. The little line thing. And x plus 3.
Hey, good job, BJ. How did you know you could use synthetic on that?
Because
X is by itself, and then a constant. Okay. Placeholders are crucial here. If you don't have them, your answer will be wrong. So always, always, always look for placeholders before you start. All right. Do you have this one already worked out on your paper?
Well,
Goodness. There was a reason I wanted you to pick one you'd already worked.
Oh, hold up. One that I already done.
Well, no, we already wrote this. Everybody already wrote this on their paper now. We'll do the new one in a minute. All right. Okay.
Oh, shucks.
Now, here's what I'm going to do. I'm going to take, we all agree this would take a while, right? Because look how long that top is. In fact, let's just do it. It's a good thing to do for review anyway. Let's do it with long division and see what happens. We got x plus 3. Do I need any placeholders? What goes up top first? X to the third, because it's x times what gives you x to the fourth, so that would be x to the third. I multiply around. X to the fourth plus 3x to the third. Subtract. Oh, this is that one where everything started canceling, isn't it? So I get negative x squared, and I'm going to have to bring down the next one too, since there's 2 terms outside. I need 2 terms there. What do I multiply x by to get negative x squared? What is it? negative x, right? And I multiply around negative x squared minus 3x. Negative x minus negative 3x would be positive 2x. Bring down that next term. Now what do I need up top? 2. So I put the 2 up top, multiply around. DJ, you should write this on that paper. You haven't done yet. Have you already turned it in then? Oh, okay. So 2x plus 6, and then of course whenever I subtract, I get 0. Okay, so the answer to this, whenever I did long division, you see how long it took, and I went I think I went fairly fast through there, right? I wasn't slow. I mean, I feel like I went at a speed y'all would go for that one if you're working it on your paper, maybe a little bit faster. X cubed minus x plus 2, and I don't have a remainder here. But if I did, it would be, of course, over x plus 3 like that. And I wrote that because I want you to see I'm fixing to make a connection here. Well, some of them they have to be done that way. If it's like if that was 2x plus 3, I wouldn't have a choice but to do it that way. No, you wouldn't write the remainder, but I just did it so you could, because I'm going to make a connection in just a minute. All right, let me set up synthetic for you. All right, you have to listen closely to this. It's hard for me to write steps for this because it gets confusing, but once you see it, the pattern's so easy to pick up on, you'll get it. All right, so I'm going to bless you change the sign of this number. So change the sign of the constant. So that's a -3. Now I'm going to do an upside down division sign, and inside this upside down division sign, I'm going to leave enough room for 2 rows. Just like this. Again, don't get frustrated with it because it looks very foreign when you first see it, but you will quickly get, everybody always likes it once you get the hang of it. All right, the first row is going to be a list of all coefficients of the top, including placeholders. Okay, so coefficients of the numerator, which would be 1, 3. What's the next one? No. -1. Y'all ready for the magic? Okay, ready or not.
Absolutely not.
Thank you. Drop the first one. That's what I always say when I do this. Thanks for stealing my thunder, Logan. All right, now we're going to take this number on the outside and we're going to multiply. What do you get? And that goes here. And now you add this column. What do you get? 0. Now the process starts all over again. I take this number, well, no, you only drop it the first time. And then from there, you multiply, add, multiply, add, multiply, add. So I'm going to take this number on the outside and I'm going to multiply. What do you get? 0. That goes up here, and I add it. What do you get? Do it again. Multiply 3 and add it. +2. Multiply it. And add it. Okay. Now you might look at that and go, that's all well and good. What the heck did that do for me at all? But I want you to go back and look at that answer that we got. In fact, read me the answer that we got whenever we divided. X Come on, y'all can do this. X to the third squared. Oh, no, just X, you're right, plus 2.
Good job, BJ.
Does anybody see the connection here? What? Okay, so this and this, is that what you said? The constants and the coefficients. Actually, this is a listing of the coefficients of the solution, and it starts with the remainder. You start at the far right, and so this is remainder, nope, constant, x, that's right, and it would keep going. So my answer when I divide this would be 1x cubed. There's no x squared, so I leave it, minus 1x, that's that one, plus 2.
Gosh, sorry. Pretty good. Yippee. I think we'll be very strong defensively with this.
Oh my gosh. This is typically something I would do this with something else because it's such an easy lesson, but we're going to just do this today and have lots of practice with it to see. That is not true. Do not say that. That's not nice. All right, give me another one that you've done. Well, I'll give you one. Or you got one, BJ? Okay, give me one.
X cubed minus 2x squared minus 4 divided by x.
Can I use synthetic division here? Yes.
Yeah.
What goes outside?
2.
Positive 2. That's exactly right.
And then we got
Upside down.
-2 and -4.
No.
Why? I thought you said it. Oh wait, we need a 0.
We need a placeholder. This is whenever it's, so in long division, if you don't put a placeholder, it can throw you off and you'll usually come back where you need to. If you forget it in synthetic, your answer is completely wrong. So you have to remember placeholder. Yeah.
Why is that 2?
It always changes signs on the outside.
We have 1 -2 0.
All right, we're going to drop the first. By the way, what'd you get, BJ, whenever you did long division on this one?
2x squared.
Okay, that's not right. All right, we drop the first, multiply around. 2 times 1 is 2. It goes up here, and we add. What do you get? 0. Multiply around, what do you get? Multiply around, what do you get? Interpret your answer. That means x cubed minus 2x squared minus 4 divided by x minus 2 equals, yes, x squared. Now my remainder is -4. That's exactly right. -4 over what I divided by. Does that make sense? One more. See how fast they go once you get them? They'll be boom, 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 boom. We probably should do another lesson with this because this is going quick. Yeah.
So, it's kind of going back to this, because I was trying to find out if it's, how is it not 2 because it's x squared? Is there not like a 1 in front of it?
Yeah, there's a 1 in front. So what do you multiply x by to get x cubed? 1x squared.
really need some.
I have you 25 of these. Let's do one together.
Evens.
They're super quick. You try this one. This is number, actually here, why don't you hand everybody one of those? Come on, put his lunch down.
I am going to have your peanut butter soon.
Oh, yeah.
Only odds. Only odds.
All of them
I'm just kidding. Only evens.
and the odds. I just want you to see, yes, this is a different variable, but you do it the same way. Divide. Mark, set, go.
No. Miss McGee, can you please do only evens?
Is this just 5 parts and there's homework too? Please tell me about this. Just 25 parts.
It should be quick, though. I don't know, because if I call it homework and don't take it up before you leave, a lot of people won't work the whole time.
I have a 20.
I won't do that. I'll set a game. I don't want to do homework when
We just gotta win.
Charlie, do you want to get this one? Do you want to get the answer?
No, this is number 25.
Yo, customer service.
Thank you. Ooh, did I do that right?
No, you need a
Opposite
placeholder.
sign. You're right. 5, 4, 3. I broke my own cardinal rule. Thank you. I appreciate it. Still gonna, my numbers are still gonna be huge.